thank you again for presenting, for giving the opportunity to make this presentation. I'm very excited about this topic, so we'll walk through it here. So anyway, I've been working on this for the last year. Been working with AI connected to Capella, and using Capella to help leverage the model that we're using. So I'll get into some details on that. First of all, material that I'm presenting today, just a little disclaimer, these are my views and opinions. Material that we're presenting is very forward-looking. None of this is officially the policy of, say, support my work. And anything that we're presenting today is an indication of future product, but I am running the content that I'm showing today on some of our products. So just to let everybody know. Now, in the course of the presentation, I'm going to basically divide the presentation up into 3 parts. First is going to be around the current state of what you can do with large language models with SysML and SysML v2. The second one is basically building an augmented retrieval generation notebook knowledge partner based on Capella. I was able to do that. Some of this material is published on my YouTube channel. If people know me from YouTube, I have a channel on innovating with Capella. I've actually posted the presentation on using a RAG implementation on that. I presented that also at an INCOSE working group. And then today is new content that we're going to be showing you around developing an agent based on a knowledge partner for leveraging Capella. I'm going to talk about its capabilities, its architecture, a demo, and I'll even show how I've actually developed the architecture for this agent with Capella. So actually using Capella to help develop it. But before I get started, I want to set the stage a little bit to the discussion and the demo I'm going to be using. I have one of my friends, we got on the phone, and I basically, and this is pretty much a real live scenario of working right now within Siemens and basically embracing both system models and AI.
Hey, Sanjay, thank you for jumping on the call. I just wanted to show you some progress that I've made along this knowledge partner to help the sustainment engineer. We've been talking about this for a while, that we really need a way to connect from basically the information that's coming back from the field that we're collecting with our various tools. And we want to be able to get that information back to the system model. And we basically want to help the sustainment engineer out. And so, I just wanted to make sure that we're still on the right track here with this.
Yeah. So with sustainment engineers, Tony, what we are seeing is there's a lot of pressure there. Now they have very much, they've got with MRO efforts and other things, they are under the gun for time on wing. If it's an aircraft engine, if it's landing gear, avoiding aircraft on ground situations. So they need really access to expertise, data quickly. And today it's a very, it's an exercise in data archaeology and accessing the right experts. What we see happening in adjacent fields like manufacturing is extensive deployments of agents, like they also call them co-pilots, where maintenance engineers who are very close to sustainment engineers, they have access to information on this complex capital equipment, maintenance manuals, access to experts, knowledge bases. This is exactly what sustainment engineers knew, but nobody addressed that yet because the data is spread across this entire cycle from beginning all through the various systems. An effort like this will really close that loop that you're showing over there between field maintenance and the upstream systems level people who have the big picture in mind.
Okay. Well, great. Well, stay tuned and let me walk you through what I have here of where we've gotten and how we can leverage AI to build a knowledge partner that can help these sustainment engineers. So thanks.
Okay, so that's my little intro teaser that we have going on here. Again, where I'm going to focus today is basically using a knowledge partner for a sustainment problem. I've actually have some demonstrations of using it on publish some YouTube channel stuff on using it to actually help develop solutions. But since most of us are already very much very much involved with developing already Capella models, I'm not going to go there, but it'll blow you away, just even the things you can do with AI and basically developing requirements and things like that. So, but this is really kind of an interesting challenge here where, we have somebody who has no knowledge of what you may have in the system model and wants to basically get some good information from it. And that's kind of the direction why I chose this one as an opportunity today. First of all, how did I get started on this? Let's take a look at what current state large language models can do with system models. I basically got engaged with this because I've been looking at SysML v2. We've been making some progress with our Siemens products on it. But part of my concern is, and things were keeping me up at night, is the large language models and the AI going to actually make that stuff irrelevant? And I really wanted to be able to see what large language models could do. Last year, around the same time, I started looking at, and actually I started evaluating whether large language models could, handle SysML v2 textual syntax and could reason on it. There's a great textbook out there that kind of walks through a whole bunch of use cases. And from that book, you can find out that it can read and write code very well. Large language models can. You've probably written some code with it or have tried to. It also can read SysML v1 diagrams. So you can actually give it a diagram. And this textbook will attest to that. And it'll read the diagram and it'll interpret what's on the diagram because it knows SysML v1. It's a very common language. It can also reason on SysML v2 textual syntax. This is something that I saw that evolved quite a bit over the last year. I mean, I tried it last summer, didn't have much luck. By around March of this year, its ability to reason on textual syntax actually was quite good. And also, it can even start generating SysML v2, especially if you do some training, and that's actually covered also in this book. My own experience with it, this is actually an example right here of a SysML v1 model. I actually have this model also in Capella, but it actually can show how you can actually go and parse the diagram, get information out of it. In my spare time, I actually teach a course at Penn State University on architecture, and SysML v1 is part of that. So we use AI in this way in the class to help people be able to look at the data. We also have, within Siemens, we actually have a tool that can allow us to convert a Capella diagram to SysML v2. And so actually that's what I use to experiment with large language models in SysML v2. We actually can translate all the phases of the Capella model over to a SysML v2 representation. Now, when I tried this, one of the things I found right away is the large language model could not handle the entire model. It could only handle a portion of it. So I took the logical architecture, which is essentially similar to what you just saw in the SysML diagram. I was able to bring that in, and I was able to build a very detailed prompt to basically, using the terminology of Arcadia, I could basically parse that model, load it up, I could use it, and I could actually then generate reports from that SysML v2 representation, which was quite cool. I mean, it could actually tell me what the components were. It could look at functions, and it could even detect things like functional chains. Big deal, man, being able to see the functional chain. So, however, I wanted to really do something. I wanted to explore this more. And so then that's where kind of part two is I wanted to see what could I do with the Capella model, because there's still quite a bit of limitations with using SysML v2, and one of the main ones being size. The size of the model is kind of a key limitation. So I started looking at, well, what could I do with Capella? How could I make this work with the Capella model? Or should I just jump to SysML v2 and make it better? So I kind of started with SysML v2 as the basis. So I kind of did a little Pew analysis on this. And so I said, okay, well, SysML v2, this is where I'm at. Some of the problems that I was having, because there's no semantic aware APIs, basically a concept like a functional chain, I can't retrieve that easily because there's not a semantic aware object called, functional chain that I can go get and manipulate. And then let's say if I have a functional chain, I can find a lot of things from it. I can find all the functions related to it. I can find all the components related to it. I could do some really cool things if I had that semantic aware API. Well, I don't. But I looked around and I said, okay, what other options do I have? SysML v1, doing this on SysML v1 would be a nightmare. There is no underlying semantic representation that I can work with. But Capella has a very rich set of semantic APIs, and there's two sources of where I can do that. One is Python for Capella, and the other one is the InfraGo organization's utilities around PyCapella MBSE. And so there's a big plus for it. Next, I needed to provide a static representation of the model. We have that, again, with the information that's in the ARD and the AFM files, and again, a public API that I can get to that static representation. And I could build a static representation of the model fairly easily. And that's what I started doing. And actually, over just a period of a couple days, with the help of AI, of course, I was able to generate code that could build the static representation that I could then turn loose to a large language model. And then one of the last things that's really important is that if I'm going to use AI and talk to it and do analysis on the model, I need a higher level language that I can talk to. I need a language myself to talk to AI. And Arcadia is a perfect example of a higher level language. I can talk in terms of components. I can talk in terms of functions. I can even use concepts like functional chains. If I have to do that same thing down and with the nuts and bolts of parts and activities and actions, that's much harder. So the nice thing I've found is a well-known method helps a lot when you're interacting with a model and also doing scenarios of it. So you'll find on my YouTube channel, I kind of walk through this RAG solution. Basically, the RAG solution allows you to identify a project for analysis. It gives you the ability to have prompts for model content for analysis. It can create structured content, and that's essentially the fabric is what I'm creating. I'm creating essentially a digital fabric from the Capella model that I can then hand off to AI so that this fabric can be turned into clothing. I mean, that's essentially what I'm doing. And basically think of the model that you have as a lot of content in there. I need to basically create the fabric first, and then with that fabric, I can go and do it. So what I'm able to do is actually I have a little UI that I can basically use to seed the fabric. And one of the things that you might seed the fabric with is a diagram, and because there's lots of information on the diagram. And all that information on the diagram, then I can then use to collect up everything. And with the information that I collect up on the diagram, I can collect up the components that are on the diagram. The components can lead to the functions on the diagram. If the diagram has a functional chain, that's on the diagram. So essentially, I can build up a fabric of information that I can then feed AI. The next thing I do then is I can run default prompts through that AI and eventually get to an interactive chat. And then with that interactive chat, I can use the fabric I can ask it about functional chains and how they're related. I can ask it about information on components. I can have AI format all that information. Essentially, the architecture that I developed in this RAG-based solution is this. Basically, I create embeddings that allow me to search for these objects in the model very quickly, such as a diagram. And then once I have that diagram, I can create this structured input file that I have here, and that structured input file can then be fed to the large language model and basically used to reason on. So that's kind of the content, and the success with this was really quite exciting. Just in this alone, I could use the large language model to essentially see my model. So I could have essentially ChatGPT 4.0, which I'm using, look at the model I'm building and actually make critiques about it, make comments about the model, even generate requirements on element of the model. Essentially, the model now is my shared whiteboard with a large language model. So I'm able to do that with it. And lots of fun things you can do. You can do requirements again with it. You can do verification. You can even use it to help enhance the architecture. And that's one of the cool uses of it. Now, next, though, it still wasn't enough. I wanted more. So I started looking at agents and what we can do with agents. One of the problems with this RAG-based approach is it's still, some of the advantages of it is that the notebook could be replayed. So that's one of the things that I could replay the notebook. So I really like this idea of using a notebook. Jupyter Notebooks and Python are widely available. That's what I was built upon. And the notebooks could be used to bridge across tools because I could write code to talk to requirements, to PLM, even to risk management systems. However, the limitations are the notebook required Python. So I you had to have some coding skills. The code is also frequently required for common activities like loading up a data file. Also, the code is required to interact with these other systems. So bottom line is the adoption curve is challenging with this. And so I really wanted to see if I could solve that with an agent. And I actually tried 3 times and failed. And finally, on the 4th time, I basically got ChatGPT to realize that I was in a fight or flight situation, and I was basically flighting every time I tried to get into it. And basically I asked that, you need to help me come up to speed on this. But I also wanted to set some, really high goals of what I wanted the solution to do, because again, I really love this notebook idea and being able to run it. But agents kept bringing me back to, let's go and do something with it. They can guide and facilitate use. They can make decisions and take actions without really constant instructions. They can be used to integrate multiple tools. So that's kind of cool, is that I could have the agent do something on my behalf by go get and gather information. They can also be made to collaborate with other agents. And they also can do some very repetitive things over again, because you can automate, set a whole bunch of information on a prompt and it could automate the whole prompts. This led me then to say, okay, if I'm going to do this and I'm going to do this right, I need to really develop the solution out. So I started developing out, some operational capabilities around requirements, some around architecture. Most of these I already kind of knew that I could do, verification. But then one thing I really wanted is I wanted this ability of this agent to create a workflow. I actually wanted the agent to basically make a replayable notebook, because having a replayable notebook would allow me then to do interactive session once, but then I could replay it. And by having a replay, I could just maybe change one or two things and basically get a deep detailed analysis or whatever the action was I was doing for it. And so I started then developing out this architecture very quickly. As I was developing the architecture and reading white papers, I realized, okay, I need to document this because there's a lot more moving parts here to building an agent than just what I thought it was going to be. And so moving into this phase, then I started documenting what the agent would have in it and all the different various components. And some of the components we're going to see today demonstrated, I'm going to run a video here in a minute, are around the interactive console, the concepts of different types of memories, the invocation of tools. And one thing that's really important is prompts. Prompts can be very complex, and so you don't want to be building them on the fly. You want to be able to use ones that you've used before. And that was one of the things that really were kind of guiding my overall view of what I wanted to do. And so now I'm going to take a little pause for myself, and I'll take over and I'll present a video. Any questions before I do that? I'm watching I see some Q&As. I'll just take a real quick look at those. Okay, nothing going on. Okay, and I'll get started. So again, if the audio is a little low, let me know. I've got a little button over here I can push, and I can crank the volume up to the microphone. Okay, thank you. Okay, so what we're going to do is we're going to take a model first of basically it's a landing gear model, and we're going to play this role of the sustainment engineer. And I'm going to actually walk through interacting with the knowledge partner to basically go and get the information out of this very detailed landing gear model that I have, and basically reason on it. And the landing gear model, as you can see, has functional chains in it. It has various components in the landing gear. It's a fairly detailed model of the basically the physical architecture.
Now we're going to demonstrate this SE knowledge partner at work. We're going to start with a notebook that is going to run and essentially launch the agent. In this case, I'm going to initialize the notebook with basically creating a package that we use to kind of capture all the information around these artifacts. Then I'm going to go in and actually load up a model, and the model we're loading up is the one I just highlighted in the previous slide. We're going to load up the model, and then we're going to load the prompt path. So I have a number of prompts that have been pre-set up and built with basically a prompt builder, and we use that then as the prompts in the activity. So we're going to start through this exercise. I'm going to run the notebook, which will fire up the agent. And the agent now is active. So you can see the agent down here. I'll scroll down a little bit. You can see the interactive display that we have with it. We've got prompts that can go in here. I have this kind of the state of the system. You can see the prompt path has already been loaded. Also, the Capella model has been loaded. So we can see the Capella model as an artifact. So we should see them in the artifact memory. And then we see a list of running the tools that we can run over here. We also have a prompt view where I can look at prompts. And that's what I'm going to use first. Is I'm going to do the system analysis of the fault code from PAB. It's actually been selected by default here, the first one. And this is what the prompt is. You can see pretty detailed prompt. You know the model based on system engineer Arcadia method. knowledge of aircraft systems as defined in ATA. So basically telling the agent that it knows about ATA spec 100. It's going to basically go in then, and its role is to basically classify the fault. So we can move this down a little bit. And we want to classify the fault, basically put the information in, and then we want to do some steps. And we'll take a look at this a little bit more once I load the information in. We'll take this prompt and we'll actually load it in, and it'll get filled out. Now what I'm going to do is I'm going to do analysis on a particular type of fault for this sustainment example. This is the fault that we're getting, and I'm going to just cut and paste that in here. And the fault we're doing is around nose wheel landing. Gear is retracting 30 seconds slower than nominal. So I'm just going to type that in, and that's going to be the fault. So we're going to use that fault and insert that into the prompt. I'm going to then scroll down here and basically save this prompt as an artifact. So now the prompt has been saved. You can see here's the fault, the prompt right here. So now I can show that artifact, and we'll see that it's been built out and it's in memory. So I'm just going to appear to the chat window and say, show the artifact. And you can see that I'm just typing in the name of the fault there, and I'm going to execute that. And it's going to give a detailed display of what the artifact is. And you can see here's the content of the artifact. And you can see here the full description of what the prompt is. You can see that it's inserted in the fault message. Nose wheel landing gear is tracking 30 seconds. Has been inserted into the prompt. So that's what we're going to use to act upon. Now, the next thing I'm going to do is I'm going to load this fault. We mentioned earlier in the architecture that there's a workspace memory. So now we're going to basically move this into workspace memory so we can work on it. And the workspace memory object, you can see here, is empty right now. And so when I do the next command, I'm going to move this memory in. So basically, I want to be able to let the agent work on that prompt and basically do something with it. So I'm going to load the prompt into the artifact memory, into the workspace memory, and it inserted it in now into workspace memory. If we look down below here now, we see that the workspace memory has been populated with the object. There's the workspace memory. So now we have it in the workspace memory, and now we're actually going to act on it. We're going to act on that prompt. We want to basically execute it. And you notice in the prompt, when we looked at it earlier, it had multiple steps. And some of the steps are basically going to be, each one is going to be creating a different artifact that we're going to use in the next step. So here I'm going to do that step, and I'm basically saying plan and act upon the workspace memory item, system analysis for fault code for PAB, content. So it's basically going to work on the content from it and do the actions that it wants it to do. Now in this, part of one of the actions was, and this is the prompt right here, it actually says what it's going to do. One of the actions was to create a payload, an object that was the prompt. So this is the prompt that it's going to create. Created a prompt, and also the other one was to create a rationale. And so now I can go and inspect both of those and see what the action was from them. So the first one I'm going to look at is I'm going to show what the prompt was that it built. And you can see down here the prompt has been built in the artifact section. You know, this is going to be the prompt that it's going to be. It's physical architecture diagram. It's going to look up nose wheel landing gear functional chain. So basically, it's used the information from the ATA spec to you know, basically fill in the field that I wanted to fill in on the aircraft system. Now, the next thing I want to do is the other artifact I created was a rationale. So I can go and look at what the rationale on why it picked that system, and I can execute that. And here's the rationale object. I'm dumping it, and it says basically the system is responsible for operation and control of the nose wheel landing gear, and which delays, and the section DAT relates to the section discusses the hydraulic electronic components. So this gives us some rationale of why it made a decision. Might be useful for tracing some history of it. So anyway, it gives the information of why the agent basically chose to substitute in nose wheel landing gear into the aircraft system. Now, the next thing I'm going to do is I'm going to do some cleanup here just for some future steps. I don't like this name that's been automatically defined to the Capella model, so I'm just going to go ahead and rename it. And this is, again, kind of using a tool to do the renaming of it. I'm just going to rename the Capella model Aero model. And we can see and that's been done. The agent basically did it, said that it renamed it Aero models. Now I have the name there for it. I'm also going to, okay, that's good. And then the next thing I'm going to do is I want to query the Capella model that we have to basically pull out the diagram that we want to search. So to do that, I'm going to put in a prompt here, query the Capella Aero model with a prompt name PAB system FC, which we looked at earlier, basically substituted a name. And I basically want to pull out the top hit for that object that's in the Capella model. So essentially I'm going through it, trying to find the object that we want to work on so that I can use that then in the future section. And so it found the query, so it created an artifact for it. And it's created an artifact called Capella selection. And what I'm going to do is I'm going to rename that Capella selection. So again, it's a simpler, nicer name than the UID for it. It was assigned automatically. So here's I renamed it Capella selection, and I can go and see what it selected. I can look at it. Yes. So now I'm going to look at that Capella selection, and looking at the Capella selection, you can see that what it picked out for the diagram that it wants to use for it. And see, there's the diagram name. So it found a diagram that matched it from the information that we provided. So that's the diagram that's going to work on, and that diagram is the one we basically pointed to earlier that we're going to be using the analysis on. And so now what we want to do is we want to bring that diagram, and essentially we're going to create a fabric, a digital fabric that we'll basically be able to use to do the reasoning on. So next step is we're going to create that fabric, and I call it an Arcadia fabric because it really, the Arcadia, this type of fabric could be created also from SysMLv2 if it was using an Arcadia library. So I'm going to create that library, the fabric for it. So now it's generating a tool to generate the Arcadia fabric, and it created the fabric information. Now the fabric is much larger than what we've seen before with the information. It's going to have all the data that's associated to that diagram brought into it, including the functional chain. So everything is brought into this fabric. Essentially, the fabric is a representation that the AI can use and work on. So now the next thing I'm going to do is I want to basically go and use a prompt to do the analysis on this fabric. And now the prompt we're going to use has also been pre-created. It's called fault message analysis. This is the fault here. It says what would be the cause of this fault message, indicate the specific impacted functional chains and components, be verbose, basing on the model content and aircraft knowledge, explain the relationship of the components in the delivered functional chain, what would be the long-term problem if the issue persists, give discussion based on specific components and long-term impact. So that's basically what we're going to ask for the agent to do. The only thing I need to do here then is to substitute in the actual message that we used earlier, also in the other prompt. I'm going to substitute that variable in, doing that right there. So it's going to substitute and fill in this field here, and I'm going to basically save that as an artifact. And you can see the artifact field now gets updated with this fault message analysis. And now what I'm basically going to do is I'm going to reason on that fault message analysis with the model. So then I'm going to use this command to basically do the reasoning. And this is now the agent now is going to go reason on it, reason on the CS fabric. Then that's the fabric that we have here that we created and I renamed, or was named automatically. And then I'm going to use the prompt fault message analysis to do that reasoning. And it will then do the reasoning and actually put the report back onto the display. And you can see here what would be the cause of noticeable landing gear retracting 30 seconds slower from nominal, indicate the specific impacted functional change in components. V. Bravos, basing answer on model content and aircraft knowledge, explain the relationship of components, delivered functions, model content, what would be the long-term problem if the issues persist, give discussion based on specific components and long-term impact. So you can see the prompt is taking a little while to respond. That's because it's going out to the large language model and executing the prompt. And here's the reply. So giving introduction, 30 seconds longer. It's giving me what the functional chains are. Specifically, I had a retract and extend functional chain. I have supply hydraulics functional chain. It gives the actual components, the relationships of the components delivered. It can give you some idea of long-term problems and basically gives you a conclusion of it. So that's essentially the full-blown analysis of the problem, basically having the agent act as kind of a system engineering knowledge partner and doing the analysis of it and putting the information together. So anyway, that's it for my demo.
Okay, so continuing on, one of the things that as I exit that notebook, I actually then create create another notebook that's called an agent replay notebook, and that notebook will actually have every step that I took in a notebook that then I could be used to replay. And then in this particular one, I could go in and then change the fault messages that are embedded in this notebook and essentially get it to run the same analysis again, but just with a different fault. And again, taking the notebook, changing maybe a couple lines of code, adding in a place where I plug in the fault message, then makes it even easier for the sustainment engineer to basically do the analysis on the problem. All they would have to do is change the fault message. So now I'm just going to go and do a quick review of some of the elements that we saw in that demo. First of all, we have an interactive display, and this interactive display is a little richer than you might see with a typical large language model. Again, it had information on the state of the model, the state of different elements of memory, and also had a way to actually go and select basically an archive set of prompts that I've created. And I actually have a prompt builder to help build the prompts. I have actually 3 different types of memory when you think of it. And if you do research on knowledge, I have a long-term memory, which is essentially the model. It could be data that's in your files. It could be data in PLM. That's kind of my long-term memory. I have short-term memory, which I refer to as artifacts. Artifacts are my short-term memory. I use them as inputs and outputs to tools. So the tools are actually looking for artifacts and basically creating artifacts. And then essentially there's a third memory called working memory. The working memory is actually something then that can be used and manipulated. So essentially I could bring in an Excel file, for instance, manipulate the Excel file, then put it back out. I can bring artifacts into the working memory, or I can basically use tools to work on it. So the advantage there is I'm not consuming resources of the actual agent that's interacting each time. And in the case of like when I was doing the analysis there on the whole model, I actually spin up a separate large language model just to do the analysis. Again, I have the replayable notebook. So the notebook is actually created after a session. This can even be made a tool so that even during the session, you could invoke the notebook tool to create whatever you have at that point in time. And this is using technology called LangGraph that basically is being used to capture all the steps of my interactivity, my actions, and doing the work on it. Lastly, these are the tools that I've put in place. Again, I can actually dump these tools with a command, show tools. I can even ask the agent to tell me how to use the tool. So I can actually the agent can tell me how to use it. And so see, I have ones here around prompt management. I have one around this workspace, the moving stuff from memory. I've got some around reading CSV files and writing CSV files. Again, the idea is I don't have to write code to do the things that are kind of common exercises that a system engineer would do. I have prompts, which are dedicated UI. And as you can see, the prompts that I was using were not trivial. And that's the truth. Once you start using AI, you'll never have a prompt that's one line. There'll always be 4, 5, 6, a half dozen lines. In this particular one here, you can even define roles. I can also do what some people you may have been exposed to, crit prompts, where I can turn the agent around and the agent can ask me questions. So I can actually have the agent give me, get more clarification on the fault message if I had it. So I can actually turn the agent around and actually have an interactive display. And finally, here's when we have large tasks, I can actually spin up a separate large language model to do them. In the case of here of doing the nose wheel landing gear analysis, I actually spin up a second large language model just to do that analysis. And so that actually preserves the ability, the tokens of space. I don't consume it. And one thing that is interesting and where I'm going is I already have 2 different contracts. The agents are guided by a set of rules that you basically give it. In this case, I have one set of rules that are my normal tool using contract, but I also have a separate contract for a set interactive session. And essentially, I end up implementing a state machine. So I'm depicting here a state machine that basically I have the default contract, and then I jump over to a session contract that allows me to do interactive sessions, essentially where the agent could be polling me for information. So anyway, kind of in conclusion then, agent technology really can be very powerful. It can help assist the user. They can guide and facilitate. The agents can act autonomously, and you saw that some of that in this example here, where I use a multi-step prompt where it was actually going out, looking up an ATA spec, and I did not supply it the spec. That's general knowledge. Find the right name to substitute into a diagram. So again, if you have diagrams in your model that were already set up to match ATA specifications, I could have that laid out that way. As you notice, the diagram the actual image doesn't become that important for the Capella model because it's actually working on the model representation. The diagram is just used as a collector or as a collection that I can feed the large language model. The fabric is I'm using Pi Capella MBSE APIs to create the fabric, and basically just pulling it in. Creating the fabric is essentially a YAML representation, which is very easy to read. Other representations would be JSON, could be used instead. And in the case of SysML v2, the textual syntax works pretty well as the fabric. The agent is shown to help users do a task. Again, I have the ability to have sessions where I can launch a session where I can have an interactive session with the agent and have it query me for more information so that it maybe go to the next step. And I see here that I've also demonstrated that I'm creating basically a replayable scenario, which then could be used to summarize, do analysis, or do the same analysis over again. One thing all through my career, I never liked doing repetitive tasks. I always figure out a way to automate them, and this is a way to automate those repetitive tasks. Where I'm going from here, next steps, I'm going to continue to work and extend the knowledge partners. I'm very excited about having this knowledge partner interact with other agents. So I'm looking for agents to work with. I want to have it actually turn around and update the model. I could have it actually use a YAML representation to update the Pi Capella MBSE model. So if I'm doing a brainstorming session, when I'm in more of the design side, I could do that. I can use it to actually update requirements. Again, I could have tools that actually go to requirements tools and update requirements from what I've created. I can create verification tests, and of course, always translate to downstream tools. And then basically, I just wanted the key takeaways here. I want to go is that an AI-based knowledge partner is possible and can be implemented on a Capella model. Actually, the Capella model makes it wonderfully easy to work on it because it is a very detailed data model. And I thank Thales for being very strict on basically saying nothing goes on a diagram if it's not in the model. That's a wonderful feature of the Capella tool, is that it has all the details on things in the model. Large language models combined with systems model have a huge potential. Grounding analysis in the content of model, which basically prevents or keeps you away from hallucinations. Having that content that you're looking at, it's essentially like having an engineer again working at the whiteboard and say they start drifting off, and you just say, "Hey, go back to the whiteboard. This is what we're talking about right now." Well, that's essentially what the system model does. Is allows you to bring the agent to the attention of what you're working on. And basically the Capella can help you with your design of an AI agent. And in my case, I was actually doing that when I was designing, and I showed you that representation of the model. I actually worked with ChatGTP and was showing them the model, and it was finding me white papers, and it was giving me content for it. And so bottom line is you need to be ready for using AI, and with Capella, you can basically do it now. So just wrapping up, if you need some to get in touch with me, these are my contact information. You can subscribe to my YouTube channel. I'll keep you posted. Some of the products that you saw running today are noted down below. And then finally, here's a list of the papers that were used to create this this knowledge partner model. So, and all this will be in the PDFs that you have. So, Samuel, I'll turn it back to you. I hope I wasn't too long over the.
Actually, a bit too long, but only unfortunately. Well, it was a fascinating perspective, and really thanks for sharing this innovative vision with us. Thank you. Thanks again, Tony.